All right, so there's quite a few moving parts to this today. So the main thing that I want to do is set up two-factor authentication with Google Authenticator. We're going to get into that in a little bit. But before that, I just wanted to continue talking a little bit about LDAP and talking about secondary groups. But before that, any questions on the LDAP lab that should be due on Wednesday? Remember, if you haven't started it yet, take snapshots. If you're running any problems, always let me know. We can extend any due dates as necessary. So, questions? Is that going well? Anyone mess it up very hard yet? No? Okay. So, I think what I'm going to do is allow you to complete any previous labs for half credit going forward towards the end of the semester. You submit it before finals week, I will give you up to half credit. Still depends on its correctness. And then I will consider doing an optional final for you to boost your grade. So once you get to the finals period time, we won't have anything in class as far as I'm considering, but I think I will have an optional final for you to work on if you're interested in doing that. So keep those things in mind. So if you've not been completing all the labs, consider doing so. Get some extra points, kind of pad your grades a little bit. And I'm expecting to have perhaps one, maybe, no, just probably one more lab for the regular class. One thing that I'm thinking of doing is maybe finishing class this week. Depends if I want to get into the terrible weeds that are mail servers. In my mind, like most organizations pretty much do exchange. So do we really care about mail servers? I don't know. And honestly, mail servers in Linux are basically the worst thing in the entire world. So, and configuring a modern mail server to work correctly, there's just a massive amount of moving parts and things that can break, and it's just a bunch of weeds, and I don't really know if I want to get into it. So thinking about that, but the couple topics that I still want to cover before the semester ends are containers, kind of some different solutions to doing that. Containers are very popular nowadays for deploying applications, kind of getting environment things correct, which they're kind of fun. And then actually looking at where you can get Linux servers from, looking at how you would provision cloud Linux servers type things, and then perhaps something with the final dealing with cloud and all of that stuff. But today, I'm just going to go and look at this a little bit more. So one of the things you've noticed is I have my phone here on the screen. So throughout today, I'm going to configure my phone as the Google Authenticator with the Google Authenticator protocol and all of that, and I'll receive my authentication codes on my phone here. And that's why I have it connected, and that's what we're going to hopefully show today. Before we do that, I wanted to really quick look at secondary groups with the LDAP. So a user has a primary group ID, just like on a regular Linux system when we're working with it. And this is just not particularly relevant to any of the assignments, but I think it's interesting. And then there's these two groups. Basically, one of the things we can do is, let's say we want to promote a user to add them to the admin group, but keep them in the users group. We could add another attribute, member UID. And the first time we have to guess what the UID is, I'm just going to say 500. That sounds about right. But then I can come back and actually modify group members and add my group members to that group. And what that will look like is just like any other secondary group in a Linux configuration. If I do that, update object on test standard. So test standard had the user's GID by default. If I was to go back, I mean, just look at test standard really quick. Their GID number is 500. So that's standard. 501 in this case was the administrator group, I believe. Now, if I was to go and try and log in, hopefully, if this is configured correctly, it might have broken somewhere along the lines. And do ID, now we can see we're part of the admins group as well. And that's how you could add multiple groups and kind of do group management and permission management for LDAP. And I think that's another very important thing to know is how to do that. Anyway, so talked about LDAP, pretty much done with that now. So we're going to move on to the two-factor authentication stuff. So this Google Authenticator protocol is something we'd call a one-time password algorithm. There's a couple different ways you can configure it. I'm trying to look for the actual source code page. That's the one that I'm looking for. And basically what happens is you have this initial seed value, and you calculate what the token is based on what the current time is. So you have this secret value that is shared between the server and your phone or something like that. And then based on the time, we calculate what our actual code is. And one of the things that's very important in this scheme is that the time is synchronized across devices. And there's actually a couple other ways we can configure it, and we can configure the window size of when the codes are provided, or when they're generated, when they're regenerated, but it has to be synced across the server and the phone or device or whatever. So getting more into like why we would do all of this two-factor authentication stuff. So you can't, of course, rely on your users to set good passwords, to configure their system securely and all of that stuff. Let's say a user uses their same password across a bunch of different things. Let's say a website account gets hacked, their password gets dumped, it gets cracked, and they realize that they were using an organizational email. The attacker might pivot into your network, kind of get a foothold in all of that. But by using a two-factor authentication solution, it doesn't have to be this one. This is just the one that I think of and a lot of people use. Even if the attacker knows the password, depending on the configuration, I should say, they still can't get into your network. And this basically requires your users to be good and have strong security. So one of the things you might do this on is perhaps your backup server is your most important thing, or perhaps your accounting server is exceptionally important. You might specifically configure Google Authenticator or some other two-factor authentication solution on that. Or you have servers that have public access that are on the public internet that you also might want to protect. So the Google Authenticator protocol, even though it's called that, is completely open source. You can use, and all of the things that we're going to do today are open source. And the really cool thing about this two-factor authentication solution is there's no communication between both of the devices. As soon as you've configured the server, as soon as you've configured the client, this can be completely offline, doesn't communicate. When I log in, it doesn't like ping Google and let it know to ping my phone or anything like that. It's completely offline. It's completely based on that initial secret that we generate, and we'll talk about that in a minute here, and the current time. So that's one of the challenges, again, we talked, or I think I briefly mentioned, was getting time synchronized, and that's something that we'll also look at today. So normally when you would log in, of course, you just type in your password. What we're going to do with Google Authenticator is when we log in, we will type in our password. This is the first way we'll configure it. We'll look at a couple different ways that are kind of interesting. When we first configure it, it will prompt us for our password, and then it'll prompt us for our verification code. Basically what we'll do is we'll go into this app right here, and it has a list of all of the different codes for all of my accounts. And you might be like, oh, his Google code is right there, I can get into his account. Well, not really, because you still have to have my password. So at the very bottom of the screen, you probably can't see it, but there's this little timer revolving. So I think as it's configured right now, you have about 30 seconds or so to copy that code down and get it into the terminal so you can log in. And we're going to look at that in a little bit here. And of course, those codes get updated every 30 seconds or so. So to do this whole thing, it's not really that challenging. We have a single package that we need to do. We need to install the PAM module for Google Authenticator, and we need to make sure that our time is up to date, and then we do a couple other things. So let's just go ahead and get into it and configure a very basic Google Authenticator setup. So we got this package here. We'll go do it over here. And so we have the module installed. Now the second thing we'll need to do is actually go and install it. But before we do that, I'm actually going to switch over to the DSU user here. I'm going to run, I think it's just Google Authenticator. And this is what we use to set up the authentication for the very first time. And there's two different ways we can configure Google Authenticator. In PAM, we could configure it to basically require a user to have configured it before they're allowed to log in, or we can allow a user to log in, but if the information exists, if it has been configured, then it will prompt them for the verification code. So what I'm going to do the first time is we haven't enabled Google Authenticator, so we're going to generate the secure or the initialization token or whatever and set everything up on the phone, and then we're going to configure it, and then all users that haven't configured this will not be allowed to log in. So we want it to be time-based, and then we get this QR code right here, and it's pretty actually broken, so I don't know if it's going to work. So in our app, you'd go here, you can see I'm looking really weird. Anyway, so scan that. Now we're to this point, I'd just be like Ubuntu, and then we can start to see our codes being generated. So super easy to set up. Anyway, so we're back over here, and when we're configuring it, it creates this hidden Google Authenticator file, and that's where that secret information is stored. We're just going to accept the defaults for the rest of it, I think, for all of the time values. Yeah. So if we do come in or encounter issues, you might have to go back and increase the amount of time between new codes being generated, but we're just going to leave it as is for right now. Okay, so second thing is, let's look at the time. So right now it's 10:15. It's 10:15. So everything looks pretty synchronized. So the one thing you might have to do though is actually update the time. I don't think I have the utility installed right now, but it's NTP date, and then the NTP server that is serving the current date and time. And usually that'd be like time.nist.gov or something like that. There's a couple other ones. I think the package to do all of that is like NTP utils or something like that. But since the time was synchronized, don't have to really worry about that. Everything should be working as intended. So we've configured DSU with that secret. We've configured it on our phone. So let's go and look at our PAM configuration. Common auth, this is where we want to put it, I think. No, not auth, common session. No, I don't like that one either. Common account, that sounds about right. Forget. I have it written down over here. SSHD, yeah. So let's, depending on where we put the this line right here, we may do things that we don't want to. Perhaps we want a user to log in locally at a local terminal, configure the authentication information, and then when they're SSHing in, they're required to provide it. So let's do that. If we're configuring it in this SSHD PAM configuration, it will only apply to SSH remote logins. So one of the things that we could do is this common account is when we would see our actual password prompt, and that's where our password prompts originate from, is that common account configuration that's being included. So if we were to put, and the common auth too, so I'd treat this entire block as one. If we were to put our Google Authenticator line before that, we'd see the verification line before, the line prompting us for the code, and we'll see that in a second. And if we were to put it after, we'd see the verification code prompt afterwards. So we're going to start out, this is the first way we're going to do it, is just we're going to put it afterwards. So we take this auth required, pam Google Authenticator.so. And basically, when we see a couple things, we see a couple different words here. We see required. That means that if anything fails in this module, this Google Authenticator, it will stop processing other modules and immediately fail your login. So one of the things we see up here is PAM no login. So if your shell, or if you've specifically configured the user to prevent them from logging in, it's not even going to try and log them in. It's immediately going to fail and all of that. One of the other things we're going to see later on is auth sufficient. So when we see auth sufficient, what that means is if this module succeeds, then just ignore the rest of the modules that could fail and just allow you access right away. And one of the things we're going to come back and do is changes from required to sufficient, and then a user could perhaps just log in with the two-factor code instead of their password. So right now we're going to do that. The other thing that we'll have to do is go and configure SSH to allow challenge. Yes. Challenge response authentication. And we're going to change that to yes. Restart SSH. I'm going to log all the way out. And hopefully when we log in now, we are going to be prompted for that verification code. Take this over here. So you can see we take our code right here and just type it in just like that, 578389, and now we're allowed to log in. If I was to go back, and I believe if I mess up the password, you're not even allowed to go to the verification code step. So that's one kind of thing you have to keep in mind, is if the attacker does get a password right or something, they are notified of that even though the codes still prevent them from logging in. So just one thing to keep in mind when you're doing all of this. So again, let's say I specifically type the code wrong. I'm just going to type all 9 instead. Then it just recycles, and then I'm prompted for it again. There we go, I typed in the right code. So one of the things to keep in mind at this point is, let's say I was to copy a SSH key over to that server. I would have to type my password, and I have to type my verification code, 0. I probably messed that up. Yep, I sure did. Cool. So now that I've copied my key over to that server, just make this full screen. We're just going to stick around on this page for a while. Now that I've copied my key to that server, I actually bypass the password prompt and the verification code entirely. So there's two ways we could respond to that, kind of. We could basically disallow the usage of keys to the server and require the user to use the authentication code or the password. Or what we could actually do is require a key, a password, and this verification code, which probably would be overboard and be super annoying. But if you want a lot of security, you could totally do that too. And the way we could do that is by going into our SSH configuration and method. Oh. What do we have here? Yes, it's authentication methods. And I don't think it's configured right now. But basically what we could do is we could say authentication methods, pub key, and then comma keyboard interactive. And basically what that would do is force both the key and the keyboard. And the keyboard, what that means is the password, but it's also this authentication code that we're retrieving. So anyway, let's let me see if this is configured for letting me log in as a user. So right now we've configured it so that a user would have to manually log into the terminal to configure all of this stuff, perhaps that's what you want to do. But the other thing that's worth noting is if I try and log in as another user, it's just going to fail on me. And normally I would be allowed to log in as that user, but since the user hasn't been configured, hasn't had their Google Authenticator information configured, they're going to be prevented from logging in. So one of the things we can do is actually tweak our PAM. I logged out here. We can tweak our PAM information a little bit to change what's happening. So now what we could do is we could actually put this nulloc, I believe is what it's called. Yeah, nulloc. We could put nulloc at the end, and what that would do is allow users which haven't configured Google Authenticator, haven't run that Google Authenticator command to generate the tokens and everything, the secure things, it would allow them to log in. But if that information exists, then the user will be required to provide it. And I might not have actually even set a password on that user, so let's make sure that's happening. Ugh, so bad. Cool. And they might not be in the SSH group too. That might be another thing that's getting in the way of this. Okay. Anyway, so now I configured a password successfully, and the user was actually allowed to log in. So the thing that you would have seen before is if I would have gotten the password right, they would have just been denied access. Now, if I run Google Authenticator, actually I won't. So I'm not going to actually run Google Authenticator. What I'm going to do instead is I'm going to copy my Google Authenticator information from DSU, just so I don't have to configure it on the phone. And again, I just don't want to do that. To my test user. Is that what? Oh, I can't, because it's I'm getting off in the weeds here of stuff. Okay. All of that was to do with the file. So I was trying to copy that information from DSU to the test user. And all of that was to do with when you have these secret informations, you usually have them set to like 600 or something, which is read and write just for the user. And that's generally speaking what you have all of your private files for. So when I copied it from DSU, to temp, to copy it to test 1, it was still 600, still only read and write for the DSU user. So I had to go and change all that. Doesn't matter, ultimately. But now, if I was to log out of test 1 and log back in, that Google Authenticator has been configured, it would prompt me for the verification code. I'll take the same one, and now I can log in again. So just remember, nulloc would allow you to log in without if you haven't configured anything. So this is a demonstration, of course. If I was to SU to another user that had required that Google Authenticator, I wouldn't be required to provide it at this point. That's due to the fact, I'm so deep here in all sorts of su and sudo, but that's due to the fact that it's in PAMD SSH. That's due to the fact that we put this line inside of the SSH configuration file for PAM. If we were to put it in the common account file or something, or perhaps the common auth would be better. I think common auth is the one that actually does the password. Yeah. So if we were to put our Google Authenticator here, then if you were SUing to another user, if you were logging on a local terminal, then you'd be required to provide that authentication code. So one final configuration that I want to look at is just using the Google Authenticator code. And what I'll consider doing, there's a couple different ways that you could do this. You could do sufficient. Did I spell that right? Sure did. And basically, it will prompt us for our code. It changed, it might still work. And then all that we are required to do is type in that code. And that's what the sufficient did. When it hits any of those sufficient lines in the PAM configuration and it accepts that and it succeeds, then it just skips it, skips all of the rest of the checks and goes on. If, however, I was to give it the wrong code, I'd still be allowed to log in with a password. So that's a little bit weird. So let's look at that a little bit more. So one of the things we could actually do is, I think we could actually, let me check and look at common account really quick. I think one of the things we could do to only allow the Google Authenticator codes, we could actually comment out both of the Unix authentication, Unix authorization. I think what we're going to try and do right now is just authentication, and that will basically disable the password prompt. You might have to comment out both of them. I can't remember offhand. So I'm going to try and type in the wrong verification code here and see if it allows me to enter a password. And now we can see that once we commented out the section that does all the password stuff, if I fail my verification code, then it will bring me back to this stage. So now I'll enter the correct verification code, 399, and now we're logged in. So that's kind of also a good demonstration of the power of doing all of the PAM, pluggable authentication modules and everything. Is you can configure authentication exactly how you want it. You can really craft interesting policies to get you to a very perhaps secure state, or at least at the very least an interesting state. And digging into PAM is really, really interesting and cool. And I've spent actually quite a bit of time working on random PAM things. But those are kind of out of scope for this class. But definitely, if you're doing all of that stuff, look into PAM more. So that's all I have for you today. Again, remember the lab doing LDAP is due on Wednesday. There's also 5 bonus points if you want to do this Google Authenticator stuff. I think it's pretty cool. Not particularly hard, I don't think, either. So yeah, any questions, feel free to stick around. But that's all I have for you.